Wi-Fi Sheep would like to say a huge thank you to all of you that kindly support us. Help us continue to bring new videos like this. Join patreon.com/Wi-Fi Sheep from just $1 a month. Hi everyone, how you doing? And a very warm welcome back to youtube.com/Wi-Fi Sheep with me, Tom. And this part 2 in our Rotten Acorns series or season here on Wi-Fi Sheep. And we're looking at attempting to rebuild an Acorn RISC PC. To cut a very long story short, if you are new to this and don't know what I'm talking about, go and see part 1. Link should be on screen now or in the description to this video. But basically, the RISC PC was one of the very last British domestic PC manufactured computers. I say domestic manufactured, it was technically manufactured in Hong Kong at the time, but this was before 1997, so it was technically classed as British manufacturing. The machines were British developed and are mostly used in the UK. Now, the name RISC PC is slightly misleading. These weren't IBM PC clones. They were actually generic ARM-based machines. The A originally in ARM standing for Acorn. These were Acorn RISC machines. And the RISC PC line replaced the earlier Acorn Archimedes, which itself replaced the original BBC microcomputer system. So last time, just to recap what we did, we got the RISC PC, or that particular RISC PC, out from storage. It was in an outbuilding. Cleaned it up outside, took out what was left of the inside. Most of it had to be scrapped. There was no internals that could really be salvaged or saved. And we did a few part swaps with other machines to try and create a case that at least looked presentable. The reason I'm having to rush a little bit is I need to get this machine up and running for this year, 2025, for a couple of computer exhibitions that are happening here in the UK. In today's video, I want to have a look at internals and what on earth we're going to do for new computer bits that need to go inside the RISC PC to attempt to make it a RISC PC. I remind you, at the moment we have absolutely nothing that was salvageable. Here on the bench, I actually have this is the motherboard from the machine that was recovered from 2 years ago. And it's really annoying because this one actually hasn't suffered too much of a battery leak. The battery used to sit here, and you see the 3 points where it was soldered on. But because I think this machine was stored on its side for a lot of its life, the battery actually ran and destroyed the power supply. The PS unit would have sat here. Unfortunately, you can see that this machine has suffered a lot of water damage. There's a lot of corrosion, and it got turned on. And I don't know if you can see here, because we did try cleaning this up in a previous video. There's scorch marks and burn marks where basically all the main chips on this board, or ICs I should say, seem to have actually blown up or smoked effectively. Also, we don't know now if these electrolytics capacitors are probably leaking. They probably are. Stuff from the 90s. It was never that good. This machine, manufacture date possibly 1994. The RISC PC came out in 1994, which means the actual platform is only 29 years old, but there's very few of them left, and they weren't a huge seller, and they weren't really known outside of the UK, so they are sung a little bit rare. But there's nothing really to be done for this board. Possibly the SIM sockets for the RAM might have a recovery value. We're pretty clean underneath, as you can see, but yeah, it was a shame really, but this board just isn't going to work again. And also things like the actual ARM processor that sits into these slots, we don't know if that's any good, if that's damaged. It probably is damaged. We don't have the RAMs damaged. And even if things hadn't been shot with 230 volts of power, the corrosion and also the leaking electrolytics, you know, probably mean that this board wouldn't have worked anyway. And we did try to see if we could resuscitate it, and it just wasn't happening. So this kind of got me thinking, it's a shame that there isn't some sort of modern replacement board that we could use in place of this totally destroyed RISC PC board. The kind of remanufactured PCBs that you see for the likes of the BBC Micro, and even things like the Apple SE series of classic Mac form factor all-in-one machines, you can now get reproduction PCBs for. And I was just thinking, it's a shame there wasn't really anything done for something like the Acorn RISC PC. But why would they be? It was such a niche machine, and it was kind of a victim of the BBC Micro that at the time was still actually kind of popular, and I know my school was using them as opposed to upgrading to Archimedes or these kind of expensive RISC PC architectures. But thinking about it a little bit more, I thought actually there is something that we could use. First of all, I thought, well, maybe an x86 PC board and we could just emulate. It's still a possibility. But I thought it would be nice to have something that could run RISC OS natively using an ARM chip. This is a definitive Acorn ARM computer. It runs RISC OS as its prime operating system. It would be nice if we could at least have something that ran RISC OS natively and was native ARM. And I started thinking, well, what is there on the market that might work for this? And here is the solution. Yes, it's good old Raspberry Pi. Now, I didn't want to just stick a normal Raspberry Pi into a RISC PC case, because the RISC PC is a very large case and it would just be a glorified Pi case at that point. I wanted to do something a little more sympathetic to the original RISC PC, whilst hopefully being able to retain some use of some of the RISC PC hardware and form factor. So I'm just going to move this out the way and we'll have a look at this. Now, this is the Raspberry Pi Compute Module 4 I/O board. At time of recording, we do have the Compute Module 5, but native RISC OS doesn't run on the Pi 5. You have to emulate it or use one of these special Linux builds. That is being rectified at the moment, but as I record this, it's not an option. The Raspberry Pi 4 series, which includes the Compute Module 4, the 4 and the Raspberry Pi 400, are the very last Pis that can run in 32-bit native ARM mode, which means that the build of RISC OS that's available for Raspberry Pi can actually use and run natively. It's not a trick, it's not a version of Linux, they run natively against the ARM processor. So here is the Compute Module 4 board. And what I like about this, although it's a considerably smaller form factor, I do like the fact that we do have the ability for a backup battery. And if I just turn the board around, we've got all the I/O, including barrel power, is actually on one side of the board. So this makes for almost a perfect PCB replacement, especially for a RISC PC. If we compare it in size to the original board, here is the original RISC PC board, and here is the Raspberry Pi Compute Module. As you can see, it is a fraction, it's a quarter of the size of the original board. However, this is just the I/O interface board. I'll just turn it around the right way. The actual processor, the Pi 4 ARM chip, is not included. For that, you actually need the separate Raspberry Pi 4 compute module. And this thing is absolutely tiny. It's so small, in fact, and to save a bit of money on cardboard packaging costs, it doesn't actually pack flat. This is how it packs, by the way. It doesn't pack flat inside the box. They actually have to stack it at an angle to get it to fit. But if I just take this board out, this is a Raspberry Pi 4, which includes the main processor. We also have, in the case of these compute modules, EEPROM, which is not common for Raspberry Pi. So this actually has onboard flash storage that's capable of actually storing an operating system or a Pi image, meaning you don't actually need to use SD card. You don't need to boot this from SD card. That's quite different compared to most other Raspberry Pi products. I'll be lying if I can remember the spec of this. I think this one is 2 GB. I think it's 2 GB, and I think it's 2 GB of RAM and 8 GB of eMMC storage. Underneath, you can see it has these two very fine connectors, and it can only go, they're off centered, so it can only fit one way, and the board clips in, there we go, and fits into the I/O module, this creating basically a complete ready to go expanded Raspberry Pi 4 system in a much more, though larger, but much more tactile form factor, ideal for putting inside a computer system. Anyway, let's try out this board, and the simplest thing to do would be to get a fresh copy of RISC OS for Raspberry Pi up and running. So here on the bench, we've got the board. I've got my card reader, and I've got a micro SD card. We'll just pop in there. I'll go and plug this into the PC. We can head over to riscosopen.org and downloads the number of boards they support. They actually do a version full of a native RISC PC in the A7000, which is the budget version of the RISC PC. However, we want Raspberry Pi, and here is the current image, which is version 5.3.0. We'd click to download that. I've actually already done that ahead of time. So I actually have a build of 5.3.0 available here. So if we just go back, just make sure our drive is actually seen, which it is seen. It's here. It's not formatted at the moment. So we're going to open Bellina Etcher. And we'll flash from file. So we'll just pick the file that's on the desktop at the moment, which is this one here. Select the target, which is the D drive mass storage device, and we'll flash. That'll take a little bit of time, but we'll give that a moment and we'll come back to it when it's done. While we're waiting for Bellina Etcher to write RISC-OS to the SD card, we can do a quick power-up test just with nothing on this, just to see what happens. So first thing to do is probably just to unravel the power supply, because it's still got a cable tie, or twist tie I should say, around it. So there we are. So we can pop that in. I don't know if it's been looped through. There we go. Okay, so you can pop that in, so that'll be power. Now I've got standard USB, which we'll put into HDMI 0. That's going to the capture card. That's pretty much what we need to do just to do a quick power test. So let's power up. Oh yeah, there we go. So yeah, that's the sort of default. I suppose you could almost call it a BIOS. It's not quite, but it's what happens if there's no partition and there's no SD card in the system. It kind of boots to this sort of firmware screen and then tries to have a look for something to boot from, be it a network boot, external drive boot, SD card, or in this case internal EEPROM. So yeah, that works fine, which means it all works as expected. So hopefully, if we now put a standard Raspberry Pi image compatible with Pi 4 into this, it should just boot as if it was a straight Raspberry Pi 4. Okay, excellent. Bellina Etcher has finished, so we can eject the SD card. Let's just power down our board from its testing. Now we put the SD card in. So 8 gig card that I'm using. We might need to put a keyboard and a mouse on this, just thinking about it. It looks kind of mouse-ish. That'll do. So let's put a mouse on. Okay, so let's do a new boot of, or fresh boot for the first time, of RISC-OS 5.3.0 on the Raspberry Pi 4 compute module. Interesting. Very interesting. Okay. Just power down. No, it's not seen it. Of course, this does slightly scupper the plan if RISC-OS is not directly available or doesn't directly work. It should work. There's no reason why it wouldn't work, but how interesting. SD card not detected. Let me just have a think about this and maybe a quick read up on compute modules, because this might be doing something that I'm not aware of, he says. Just bear with me one moment. Right, I'm just having a look here, and I found this on Stack Overflow, and it talks about booting from SD card if you have the eMMC installed. And interestingly, the module with the eMMC doesn't have the SD pins wired up, so the SD card slot on the I/O board isn't going anywhere. Right, so we have to flash directly to the eMMC. We can't boot from SD card. I didn't know that. That's extremely interesting. Okay then, so in order to make that work, we need to grab Raspberry Pi Imager, and it's available for x86 or Mac ARM platforms. So I'm obviously going to download it for Windows. I think it also installs, you can actually use it on Raspberry Pi itself, so it's going to give me an installer. So we're just going to get that installed very quickly, and we'll run Raspberry Pi Imager. Okay, we'll need to shut this down, take the SD card out because that isn't going to work. That is interesting. And let's find a suitable cable from somewhere, because we need to patch from this over to Raspberry Pi Imager on the PC. This cable has seen better days, but it'll do the job. So let's just plug into the micro USB on there, and we'll plug this into the PC. So that's now plugged in. I don't know, this probably needs to be powered up as well, I'm guessing. But it says about setting jumper 2, which is this one here. I've got a little jumper. These don't come with it, so you have to fit that separately. So that now sets it to eMMC boot. Okay, so let's just try that again. Oh, Raspberry Pi 4. Choose, and we'll use our own image, which is just a copy of... Okay, just to update you where I'm at, apparently I was missing the drivers because it's not included in Raspberry Pi Imager, which is annoying. So I've had to install Raspberry Pi USB boot, which is available from the GitHub. If we go back to Raspberry Pi Imager, we'll select Raspberry 4, we'll choose again, we'll choose custom, and we'll choose the image that we downloaded. Now if I power back up my board, does it see it? It tried to see it, but it didn't. I was hoping this was going to be a bit simpler than this. I may need to restart this machine, try again. Okay, after a load of messing about, I'm very pleased to say we actually finally got there in the end. So yeah, you have to install a set of drivers, which is all buried in the Raspberry Pi documentation. Then you have to find an application to run Raspberry Pi mass storage gadget, which once you've ran that, it kind of springs into life. So hopefully now we can choose our custom image. There we go. So I click storage. So it sees, so it is 8 gig storage. Next. Do you know what? I'm not going to do that at the moment. So we'll close that. No settings on this. Yes. Okay. One thing I've got to do is I've got to take this jumper out here. Okay, let's go back and see if we get a boot. We do, but you can't see it at the minute because I don't think the capture card's working. Let's just see if I can bring the capture card back. There we go. There we go. Okay. Oh my goodness, it's actually worked. That is RISC-OS running. This is a brand new build. This is version 5.30. Goodness, we got there. It always boots into the web browser and has an offline version of the website to start with. Has a moan about not having any internet connections. That's fine. I'm not worried about that at the moment. RISC-OS Pi. So I remind you, this is now running off an eMMC flash storage, 8 GB flash storage, as opposed to running off SD card, which is how we normally run it. How cool is that? So if I now mouse or middle scroll wheel click, you can see, let's bring up some, there's the config. Have I got the about? Oh, there it is. So more memory than it knows what to do with. It's seeing a fair chunk of RAM. Excellent. So in the configuration here, we can go themes, and I forget which one it is. One of these is this sort of the native, I think it's Morris. So if you select Morris, do that, hit set. Now if we do a middle click, we shut down and we restart the system, it always gets stuck here because it tries to find the boot. So you can hit escape, just hit cancel. There we go. So it's still got a, we go to, we've still got this desktop up, but we can actually go into 640, change 800 by 600, which would be that. And if we now configure, and we can select the whatever renders pattern we want, so that one. Background color, we'll just say white. Set. I've lost some icons somewhere, but never mind. And yeah, that kind of gives you the kind of RISC-OS 3.7 Acorn Archimedes type look and feel. And that's what I wanted to go for this RISC-OS build. It's ironic, really. I've spent so much of my time, especially with developing things like RISC-OS Direct I was involved with, trying to modernize RISC-OS. And now I want to recreate something that looks like it dates from the 90s and how RISC-OS 3.7 looked on the RISC PC. As you can see, it's very easy to recreate that here using a Raspberry Pi board. And it's not just any old Raspberry Pi board. It's, of course, a compute module running without an SD card. I was just going to use SD cards, but it does have eMMC on board. Took us a while to get there, but this board is now ready and should hopefully be able to go inside our RISC PC case. So yeah, absolutely chuffed with that. We got there in the end. It wasn't quite as easy as I thought it was going to be, and there's been a slight change of plan, but the fact that the board is actually running and we've got native RISC-OS running on it, and we've been able to set it up to look like and behave like the system you would have run on an original RISC PC, that's absolutely fantastic. Obviously, we've still got a long way to go, but I think that's probably enough for today. So you'll have to join me again soon for part 3. If you're brand new around here, then thank you so much for your company, or of course if you're returning, we really appreciate you following through what exactly we're getting on with here on the channel. Before I go, a quick shout out to our Patreon and YouTube channel members. There they all are on the screen. Thank you so much to each and every one of them that supports this channel and makes this possible. If you're brand new around here and haven't done so already, please do consider liking and subscribing to the channel. I'll see you real soon for part 3. Until then, thanks so much for your company. Bye for now.